Hello class, and today we're going to start reviewing for your exam. I know we're kicking into gear. We probably have 8 or 9 classes until the exam, or maybe less. We'll have to see how time goes depending on when you listen to this video. And I want you to be prepared. So please make sure you've got this booklet handout that I should have photocopied for you. If not, I'll put one on the PDF. I'll try to PDF it in case you missed that day on my website. So we're going to start each day. We're going to try to do a unit or maybe 2 units depending on how time goes. So today we're going to focus on reviewing for Unit 1, which is Intro to Functions. I know it's been a long time since the beginning of the school semester, so we're going to go back and review things. Number 1, it says, what is a function? Just remember, a function is where each x value has only one y value. Okay? And we can take a look at that in different aspects, a list of points, or what we call a mapping diagram. So if I had something like x and y, and I had something like this, and I said for x, here's a 4, and maybe for y, I had a 3 and a 6. And if I had arrows going to both from 4 to 3 and 4 to 6, is this going to be an example of a function? Does this x have only one y? No. It actually has 2 y's, so no, this is not an example of a function. Okay? Likewise, if I do the opposite way, so say I've got x and y, and what if I choose something like this, 4 and 6, and they both go to 5, something like this. Does each x have only one y? Yes. So that is an example of a function. Okay? If you're given a graph, just remember in order to test if it's a function, you're going to use the vertical line test, VLT, and you can use that short form on your exam. I'm not worried about it as long as you say VLT. For those who forget, I'm going to write it out. Vertical line test. So you just take a vertical line, ladies and gentlemen. You go from left to right, and if it only hits that line at one point on your function every time as you go from left to right, then it's a function. If it hits more than one spot or two, then or more, then it is not a function. All right, and then the equation, that's the hardest part. So just remember when your equation, I want you to think of what the graph looks like. So think of a graph. Okay, so now you've been exposed to a whole bunch of different types of functions throughout the year. Let's take a look here. So the first equation, y equals 3x minus 4. What type is that? That is linear. So this is a linear equation where all linear functions with the exception of one are functions. So any linear relation is a function. You guys remember when it's not? Okay, the only exception is when it's a vertical line or undefined slope. Okay, that's the only exception when it is not, when a line is not a function. Okay, I'm just going to erase that so that we don't confuse people. Okay, next one, a square root function. Okay, so the next one is a root. Okay, for those who forget what that looks like, usually there's no transformations here, so you start here and it's kind of like a sideways half of a parabola. Okay, a little arc shape like that. And if I use the vertical line test, is it going to be a function? Absolutely. Okay. The next one is x equals y squared. Okay. Well, you could test it by taking a look at a value. So what if we sub in a value? What if we let x equal 4? Okay, so it's going to be 4 equals y squared. How do you get y by itself? Take the square root of both sides. And when you take the square root of 4, remember you got to take the plus or the minus. So y could be here plus or minus 2. So in this case, is this a function? And the answer is no. Okay, because there's more than one value. For example, when x equals 4, y can be -2 or +2. So no. If you're wondering what that graph's like, ladies and gentlemen, that is just parabola on its side, but it includes both the top and the bottom version of it. Okay? So if I tried to do a vertical line test, it would hit at both sides. Okay? And in fact, it would hit, if this is my actual model example here, if this was 4, this would hit at where y is 2, and this would hit at where y is -2. Just a visualization there. Okay, last one, ladies and gentlemen. If you don't recognize that, that's x squared plus y squared equals r squared. That is a circle. And what do we know about a circle, guys, on a vertical line test? That, no, it is not a function. Okay? All right, hopefully you have enough room to fit that stuff in. Keep going. Function notation. F at 2 means that what the y value is when x equals 2 instead of f at x. Okay? Then we learned how to do some substitutions here. So if we've got f at x equals 2x squared minus 3x plus 5, we want to evaluate it when it's f at 3b. So just make sure you realize that x equals 3b in this case. So in this equation, when you write it out, you're going to do some work as well to simplify. So let's take a look. So f at 3b equals 2 times 3b, but that's still squared, minus 3 times 3b, and plus 5. Okay? Do some simplification here. Use your BEDMAS. So you got to do exponents first. That's going to be 9b squared minus 9b plus 5. And just finish your multiplication again. So you're going to end up with 18b squared minus 9b plus 5. All right. Domain and range, that's another important topic, and it continues to come up in most units with the functions, different units of functions we've done. List of points when a mapping diagram or a scatter plot. So just remember, you're going to have something like domain is such that 1, 3, 5. Just remember, guys, when you're listing those points, that you put it in numerical order and you don't include repeats. So numerical order. Okay? When it's a solid line or a function, remember it's either x belongs to a set of real numbers or y belongs to real numbers, such that, and then don't forget to state any of your restrictions. Okay? When we have a dashed line, which is discrete functions, so that's our last unit 7 and 8, we have that n belongs to a set of real natural numbers instead of real numbers. Okay? And then state the restrictions. Okay? Because remember, natural numbers, you can't have decimals or fractions, so that's why we call it discrete functions. All right, moving on. Inverse of a function. Okay? So that's where f at x becomes f inverse of x. Okay? So if you have a table of values, if you're listing the points, you switch, you've got x and y values. So let's just take a look here. If I write down, hopefully I can fit it in here, -2 and 5 and 3 and -1. If I want to do the inverse, you switch x and y values. So instead of -2 and 5, it's going to be 5 and -2. Instead of 3 and -1, it's going to be -1 and 3. Okay? Just remember, folks, that works out because on a graph, x and y, the inverse is a mirror image by the line y equals x. So that's the mirror image, y equals x. So you can switch the x and the y that way. Okay? And that's what it just says here on a graph, ladies and gentlemen. For B, the reflection is y equals x. Okay? And you switch the ordered pair if you're on a graph. Okay, the equation. You switch two different ways you can do this. Switch x and y and then solve for y. But when you're solving for y, you're doing the opposite operations of BEDMAS. So you're working backwards. Okay? Or you write down opposite order and opposite operations. Okay? So we're going to do an example with showing both parts. Part A is on this side, and I think, let me double check, part B is on the other side. Yep. Or on the other page. Okay, so let's start with method 1. Okay, so I'm going to just rewrite. You can change f at x to y because it's easier for you. You don't forget that. Okay, so method 1, switch x and y. So it's going to be x equals 3 times y minus 2 squared plus 4. Okay, and then it says to solve for y. Okay, so we eventually want to get y by itself. We got to work backwards. So we're instead of doing exponents first, we're doing exponents last, okay? Or brackets last. So we're going to be taking a look at the addition and subtraction. So the first thing we're going to do is get rid of the plus 4, bring it over. So it's going to be x minus 4 equals 3 times y minus 2 squared It's kind of like stripping things away. How do you get closer to the center? Next, I realize that this thing is all multiplied by 3, so I'm going to do the opposite and divide by 3. Okay? And so I've got that canceled out, and then I have to do what? Currently I've got squared, so I have to do the opposite operation, which is square root. And when you add a square root in, don't forget to include both the positive and the negative results. How many of you guys made that mistake on your unit test? Go back and check. Okay? Okay, and then finally to get y by itself, you remove that bracket. So it's going to be plus or minus the square root of x minus 4, all divided by 3 under the square root, plus 2 equals y. Don't forget to say, therefore, the inverse function equals, and you can do it this way. You can put the 2 in front. Some people like that. Or you could say, just like you wrote down there, plus or minus the square root of x minus 4 divided by 3, and then plus 2. All right, you could have either answer. All right, let's take a look at the second method. Okay, I'm going to flip the page. Okay, method 2. Okay, so we're just going to rewrite the equation over again, which is y equals 3 times x minus 2 squared plus 4. You could have f at x there, it doesn't matter. So we're going to do the, first do the operations the correct way, and then do the inverse, which is opposite order. So we're going to start with x. I apologize, it's a spelling mistake there. So start with x. So what's happening when we start with x? First thing, look, what's happened first to x, what's closest by? So part A, you're going to what? Subtract 2. And then what's next affecting that is the squared. So you're going to square it. Okay. Then you're going to multiply by 3. And then last, according to BEDMAS, you are going to add 4. Okay? So just remember, when you go to do the inverse, sorry, my spelling is awful today. Let's see if I can fix that up for you. So when we go to do the inverse, remember, it's opposite operations and opposite order. So opposite order and opposite operations. Okay, still going to start with x. We're going to go to the bottom and do the opposite. So start with x. Okay, so instead of add 4, what do we have to do? Subtract 4. Okay. Instead of multiply by 3, we need to do the opposite, which is divide by 3. Okay. Instead of, for C, instead of squaring it, you got to do the opposite, which is square root it. Don't forget your plus and negative signs. And then D, last thing says, instead of subtracting 2, we're going to add 2. So let's build that, ladies and gentlemen. So off on a spare sheet of paper, or maybe beside here, let's see if I can do it. I'm going to take x. Okay. I'm going to then follow A. I'm going to subtract 4. I'm going to then divide it by 3. And then I'm going to take the square root of it. Don't forget your plus or minus signs. And then I'm going to add 2 to it. Okay. So f at x equals that. Okay, so I ran out of room there. Just remember, ladies and gentlemen, that the inverse is not always a function. Okay, sometimes it is, but sometimes it isn't. So let's take a look here at an example. If we have y equals, or f at x equals x squared, we know, for example, that that's a parabola, and that x belongs to a set of real numbers is your domain. And your range, because it's the base formula, is that y belongs to a set of real numbers such that y has to be greater than or equal to 0. So that's your basic parabola. What happens when we take a look at the inverse of it? Okay? if we switch x and y, so instead of the domain belongs to a set of real numbers, in range here, y belongs to a set of real numbers. Okay, because you switch x and y, so you switch the domain and the range. Okay, so that goes to here. Okay, and then we go here. So this is that x belongs to a set of real numbers such that x has to be greater than or equal to 0. Just remember, folks, though, it's the plus or minus part. So if I graph this, okay, let's just do a quick visual. Let's do our function first. So y equals x squared. Okay, I draw in my inverse line. Okay, so you flip it by that inverse line, and it's going to look like this. Okay, so what do we know about this, ladies and gentlemen? X has to be greater than or equal to 0, but is this a function? Does it pass the vertical line test? Okay, and this is not a square root function as well, folks. This is the inverse, which includes both the positive and the negative sides of it. Okay, so it goes all the way up and down. Okay, so what do we notice here, folks? That although the domain and the range can be exchanged, in this case, the domain, the inverse is not a function. So inverse is not a function. Okay. All right. Okay, parent functions, ladies and gentlemen, I would make sure you review that handout that you have. So remember how I said you've got a beautiful handout here, make it colorful. Check that out. Okay, I'm going to review some stuff here, but that's what I want you to check out. It has the 5 important steps and general shape of these. Okay, so quadratic says see chapter 3 review graph. Okay, so if you want to do that, just remember, ladies and gentlemen, when you have a parabola or a quadratic function, it's a parabola. Okay, if we have the base function, it's got a step pattern a times 1, 3, 5. We know the vertex is at 0 and 0. Okay, all right, and as we just reviewed, we'll do it again. The domain is x belongs to set of real numbers. Okay, whereas the range is y belongs to set of real numbers such that y is greater than or equal to c, or y is less than or equal to c. And that depends, ladies and gentlemen, what the sign of a is. So if a is greater than 0 or positive, it's going to be the greater than c. So it's going to be, I'll put down a is positive. So you look at that code there, guys, positive a, whereas this one is going to be negative a. So a is negative. Okay? All right, that means it's opening up or down. Okay, so the range is dependent upon c, and that's one of your transformations that you should know what that. But that's your vertical shift. Okay, or vertical translation. All right, absolute value parent function, ladies and gentlemen. Just trying to color code it the same. Got x and y. That's where you've got the v. Okay, and although we don't call it technically a vertex, we've got a key point here, 0, 0. I know some textbooks do call it a vertex. Okay, and again, it's very similar to quadratic in that for your domain and range is that x belongs to a set of real numbers and y belongs to a set of real numbers such that y is greater than or equal to c and y is less than or equal to c. And again, that depends on a being positive or negative. So in this case, I'm just going to show you with the direction of opening. So the parabola opens up, okay, and parabola opens down. Okay. All right, moving on. Reciprocal graph. This is one of the harder ones to draw, guys. So just remember that we start off with a grid x, y. We remember that with the parent function, we have 2 asymptotes, ladies and gentlemen. One's on the y-axis and one's on the x-axis. So these are your asymptotes, okay? Okay, so it's x equals 0 and y equals 0, your asymptotes, okay? And your 2 key points to remember, folks, is 1, 1. Okay, and then from 1, 1, it gradually goes in both directions to the asymptotes, but never crosses, it gets closer. So key point 1, 1, And the other key point is -1, -1. So those are the two ones you want to use to graph. And based on those spots where they transform to, you can figure out the transformations. So, taking a look at domain, it's x belongs to a set of real numbers, and we do have some restrictions, and that's that x cannot equal d. Okay, and d represents one of your asymptotes. Okay, d is your horizontal shift left-right. Likewise, with the range, y belongs to a set of real numbers such that y cannot equal c. That's your vertical shift or translation. And your asymptotes, folks, are at y equals c and x equals d. Okay? All right, moving on. Square root function or square root graph. Okay. Notice here compared to last example, it just says square root of x. It doesn't have plus or minus. So that's why when we take a look here, we have an endpoint and we just have one direction going up unless it's flipped. So our key point to remember here is we have 0, 0, and that's called the end point. Okay. So what do we know, ladies and gentlemen? We know that based on this, that our x belongs to a set of real numbers, but we got another restriction in here. X belongs to a set of real numbers such that x has to be greater than or equal to d, or x has to be less than or equal to d. And that's based on, when you're dealing with x, now we've got to deal with that stretch and compression factor, ladies and gentlemen. So that's depending on k. So this means that in this case, k, which is your horizontal compression or stretch factor, k has to be greater than 0, or if it reflects the y-axis, ladies and gentlemen, we have k. If it's less than 0, that means it's negative, so it would kind of be over here, right? Like that, guys. So that's if k is less than 0, so it's negative, so it reflects the y-axis. Okay. Taking a look at our range, ladies and gentlemen, our range is such that, I'm going to just write it down below here. So y belongs to a set of real numbers such that, two cases again, y has to be greater than or equal to c, or y has to be less than or equal to c, depending on, again, a. Okay? So let's just change it up. So if a is positive, that means a is greater than 0. And if a is negative, a is less than 0. You choose whichever method you like to describe a in this case. All right. Whew, we're almost done here, guys. Transformations. Remember, each function can have a, k, d, and c in it. Those are different transformations. Let's quickly review. A deals with direction of opening. If it's positive, it opens up. If it's negative, it opens down. Okay? It also will tell you your step pattern or your stretch factor. If A is positive, it will be narrower. Okay? And if it's negative, if it's between 0 and 1, it is going to be compressed in the vertical sense. Okay? All right. F means any function, so any function we can deal with that. K, so A deals with the up-down compression factor, right, guys? Whereas when we're dealing with K, K is that left-right, either pushing in or pushing away factor, okay? So pushing in or pushing out. Remember with K, folks, that it's 1 over the absolute value of K when you're looking for its factor. Okay, D, ladies and gentlemen, D is your horizontal translation, so either up, left or right. And the last one, C, is your vertical translation, either up or down. Okay, so when it's asking you to describe the transformations, tell me what A equals, and then describe the two things. A, it does this, B, it does that. Tell me what K equals. Tell me what that means, A or B. Because remember, if K is negative, it reflects the y-axis. I forgot to mention that as well. And then D equals tells you it's going to go either left or right. C equals 5, it's going to go up 5, etc. So make sure you know how to describe transformations. Okay? And remember that you're going to be doing some general mapping. And I will provide this formula on the exam. But what I need you to know is what each letter represents. So know what each letter represents. And there's a summary in your notes. I'm sure it's on your review for this first unit test or the second unit test. So make sure you know what each letter represents. Okay? Just remember that the mapping formula sequence will be given on exam. You don't have to memorize it, you just know how to use it. Okay? All right. Just a quick reminder though, folks, when I give you a formula like this expression here, notice the function or the f is still in it. We cannot graph that. It's not until I tell you, hey, your parent function is either square root, reciprocal, quadratic, sinusoidal. I have to tell you which one it is before I can ask you to graph it. And if you're ever stuck figuring out what's the base function given that form, you just strip away the a, the k, the d, and the c, and what's left over will tell you what your base function is. All right, ladies and gentlemen, here's your homework, page 206, numbers 1 to 4, 15 to 24, and go over Unit 1 test. Have a great day, guys.